we need to define one or two more relevant things when in the context of viscosity. In fluid mechanics and heat transfer, the ratio of dynamic viscosity to density appears very frequently because at times it changes the value. This ratio changes. And therefore, for convenience, this ratio is given the name kinematic viscosity. We have defined viscosity, and then we define a ratio, viscosity over density, and that is denoted as nu. So nu is called as kinematic viscosity. Still, essentially, it represents viscosity coefficient of a particular fluid, but it is a ratio of viscosity divided by the density of the fluid at that temperature. Two common units of kinematic viscosity are meter square per second and Stoke, and 1 Stoke is equal to 1 centimeter square per second. So you can see, and that is equivalent to 0.001 meter square per second, obviously. In general, the viscosity of a fluid depends on both the temperature and pressure, although the dependence on pressure is rather weak. You see, अगर liquids हो तो फिर तो ये इतना बड़ा मसला नहीं है, क्योंकि no matter if you apply pressure, the liquid remains the same. So, for example, if the liquid is water, it will remain the same. But if these are gases, then under gases, the density, if we apply pressure to a certain volume of gases, then the density of that volume will change, and therefore the ratio mu over rho will also change because rho is changing. For liquid, both the dynamic and kinematic viscosities are practically independent of pressure. I just said that earlier. And any small variations with pressure is usually disregarded, except at very high pressures. But for gases, this is also the case of dynamic viscosity at low to moderate pressures, but not for kinematic viscosity, since the density of a gas is proportional to its pressure. The viscosity of a fluid is a measure of its resistance to deformation. So really, basically, it represents kind of resistance, the friction in the liquid or in the fluid. Viscosity is due to internal friction force that develops between different layers of fluids as they are forced to move relative to each other. Viscosity is caused by the cohesive forces between the molecules in liquids and by the molecular collisions in gases, and it varies greatly with temperature. With gases, the change in temperature is important. The viscosity of liquids decreases with temperature, whereas the viscosity of gases increases with temperature. This is because in a liquid, the molecules possess more energy at higher temperature, and they can oppose the large cohesive intermolecular forces more strongly. As a result, the energized liquid molecules can move more freely. In a gas, on the other hand, the intermolecular forces are negligible, and the gas molecules at high temperatures move randomly at higher velocities. This results in more molecular collisions per unit volume, per unit time, and therefore in greater resistance to flow. Liquids in general are much more viscous than gases.